Hello, welcome to another video on ChatGPT from engineering for developers. The whole point of this course, or at least from this video, is to make a quick recap of all the things that I have learned so far here. So this course on core, specifically from deeplearning.ai, this is taught by Isa Fulford from OpenAI and Andrew Ng, someone that I have met before, or at least I know about him because I look at a deep learning specialization from Coursera. So in this course, they teach you how to use LLM to build new powerful applications using the Open AI or the Open AI APIs. So you'll be able to quickly build new capabilities that learn to innovate and provide values in ways that were traditional, cost prohibitive, technical, or highly technical, or impossible before now. So the course describes how LLM works, from good practice from prompt engineering, as well as how you can use LLM APIs. How you can use LLM APIs that can be used in applications for a variety of use cases. Particularly, the most common use cases are like summarizing, which is user summarizing. User summarizing or summarizing a user review for brevity, summarizing, inferring, sentiment or sentiment classification, topic extractions, transformation or transforming, like translations, spelling and grammar corrections, and expanding, automatically writing new emails. And also, they show us is two principles for writing effective prompts, as well as how you can do that systematically, or how you can systematically engineering good prompts in a practical or a project building a chatbot application. Okay, so the requirement of this is that you should understand the basic of Python, as well as all of this course will be using the Jupyter notebook environment. So that was the core preview, right? And then in the introduction of this course, Andrew mentioned that there is a lot of articles out there, like 30 prompts everybody has to know, but these are most oriented to ChatGPT web interface, which are most of the people often use for one-off tasks. But the power of this for developers, and Andrew mentioned, he think, is that it allows you to, using the API calls from this LLM, this large language model, to build software application. So that's the reason why he created a sister company from deep learning called AI Fund to do that. And they're gonna share me is how this course is made of. Like, first, look at the principles or the fundamentals. Then some of the most common use case applications, like summarizing, inferring, transforming, and expanding. And then how to build a chat app. using an LLM. Okay, so in the development of the LLM, there are broadly two types of LLM: base LLM and instruction tune LLM. So base LLM predicts the next most likely word using trained data. So for example, if you prompt something like once upon a time there was a unicorn, the model will likely to complete with that live in a magical forest with all her unicorn friends. But when you ask, for example, what is the capital of France, the model will likely to complete with what is the France most largest city, or what is the France population, what is the currency of France, because the model was trained on articles on the internet that are likely to have list of quiz. Okay, which is something they mention here. So because the articles on the internet that the model used to be trained could quite possibly be list of questions about the country of France. So in contrast with the instruction to LLM, where now it tries to follow instructions, and the way to do that is uh, it tries to follow instructions. So if you prompt what is the capital of France, it will most likely to reply with the capital of France is Paris. So the way how this works, okay, is that you start with a you start with a base LLM, you train them with a huge amount of data, and then you further training to tune in with a specific input and outputs that attempts to follow instructions. Mhm. That attempts to follow instructions. Yeah, that attempts to follow instructions, often further using refined techniques like reinforcement learning, human feedback. And this is to make the model much more helpful to follow instructions, as well as the model has been trained to be harmful, helpful, harmless, and honest. So they are less likely to output problematic. They're less likely to output problematic or toxic output. So some of the best practice you find out there on the internet may be more suited, maybe more suited for base LLM. But for most practical applications today, we will recommend to go with instruction to an LLM because they're easy to use and also because of the work of OpenAI and other LLM companies, becoming safer and more aligned. So this is the introduction of this. So first is describing is from the user perspective, okay? And the recommendation that Andrew mentioned about why he thinks that the power of LLMs lies on the development on this, as well as the couple most common use case, summarizing, inferring, translations, and expanding. And then uh, mention what are the most or the broad type of LLM, base LLM, make an example of that, as well as the or in mega So so explain base LLM and give an example as well as a contrast. So explain what is a base LLM, then give an example and see a particular example that doesn't fit what we want and the reason why we have instructions to an LLM and how it works behind the scenes, roughly speaking, and where are their principles and where are their goals. Yeah, and what are their goals? And also a recommendation on how you can think of this instruction to LLM. Think of them as person. Okay. So think of them as person that, do you say that? Yeah. Think of them as person. hmm Yeah. Think of them as person. Yeah. So think of them. hmm So yeah. So think of them as persons that are smart, but they don't have but they don't know the specific. So when you're uh, so when an instruction to an LLM doesn't work, it is because an instruction weren't clear enough. So for example, when you ask about uh, Alan Turing, it will helpful to mention about the context. So what you want to know about him, okay, his scientific works, his personal life, his role in history, or something else, as well as the tone. Giving that to give me to that as a professional journalist or something more casual. So this is the introduction. All right. Okay. First, I look at the course review. Then the course review, which talk about what are the things that you're gonna learn, uh, what this course is about, who taught this course, and the duration of this course, as well as the requirement. And then you look at the introduction, where now he describes it from the user perspective uh, and how, looking now from a developer perspective, which is where the power lies, as well as some common use case. And then the topic itself about this LLM, how this is labeled in two types. You have base LLM, what it does, this base LLM, an example of that, and then a specific example of why it doesn't is a good fit, and the reason why we have is the instruction to an LLM, how it works behind the scenes, okay, roughly speaking, and the goal of this instruction to LLM, right? That is helpful, harmless, and honest. That is helpful, harmless, and honest. And also a recommendation of how you can think of this instruction to an LLM. And roughly speaking, talk about is what you should do to get the proper answer. Like be specific and the tone here. So then I look at the guidelines, right? So these guidelines is telling you from the high level perspective about two principles, and then the tactics that each one of them implement. So the first is right click, and also which large language model are we going to use? GPT 3.5 Turbo. Okay, so we can replace this with any other large language model. So for example, there is a large language model called bar, I think it is. The large language model. Or the LSTM, long short-term memory, tokenization, output training, perplexity, BERT. That's right. This is all of this large language model that we can use, right? BERT, GPT-2, GPT-3 generated pre-trained transformer. Okay, generated pre-trained transformer. And then the boom of all this. Number of parameter 340 million. But this is 340 million. Corpus size 3.3 billion words. An early and influential language model, but a coder only and does not build to be prompt or generative. An alternative to BERT. An open AI. Okay. Baidu. DeepMind. Gopher. 300 billion tokens. 200 billion. In DeepMind. Meta and Yandex. And all of them are proprietary. Public Web API, GPT-4, available for ChatGPT Plus users and using several products. But again, exactly, it's because a lot of people are on the hype. There's a lot of hype, there's a lot of hype. There is a lot of hype like this. There is a lot of hype here. Public Web API. And then you have BERT. Free trade of deep bidirectional transformer for language. BERT 101, state of the art NLP. And BERT, which is another large language model. Expand horizon. There is no right model. There is a model that can fit your needs. That's what happened. A brief history of LLM. Scaling parameter and market. Total compute used during training. During learning. Downstream task. Data source. LLM enhanced computer vision. Writing code, controlling robots. Okay. But again, this is all the LLMs that we can, or at least this course that specifically is using this GPT-3 or this specific large language model, GPT 3.5 Turbo. Okay, all of these principles and guidelines can be applied to any LLM, right? And this is the reason why I'm looking at this, because this is the generalist. And then you can choose which tool you would like to play. Okay, so this is the guidelines, right? So it focuses on these high level concepts and then the principles, each and the specific studies and the specific tactics, okay, that will be used along through all of this course. And in these lessons, we're gonna use is the GPT 3.5 Turbo LLM. So we're gonna use a helper function to make it easy to use prompt. Yes, a helper function to make it easy to use prompt and look at the generated outputs. Yep, that's right. At the generated outputs. And then the principles. So the principle one is write clear and specific instructions. So short doesn't mean or clear is different from short. Short doesn't mean clear instruction. And there are several tactics here. So first is use delimiters to distinct. Yeah, use the limiter to distinct different part of your input. Delimiters like triple backticks, triple quotes, tags, XML tags, or angle brackets, triple dash, and this is to also to avoid prompt injections like this, prompt injections. mhm, Prompt injections. Yeah, to avoid prompt injections. Mhm. To avoid prompt injections. And avoid prompt injection is if you're letting the users to prompt your application and for some reason he wants to override a specific instruction, he knows about this. So using this delimiter to prevent this prompt injection. The second tactic is ask for structured output like JSON or HTML, right? Tactic 3 is check whether condition is satisfied and assumptions. So by providing is specific ways of how you want that particular outcome or output, as well as the assumption you're gonna make. And the tactic 4 is few shot prompting. This is more for the machine learning aspect, meaning give successful yeah, give successful examples of completing tasks and then ask the model to perform the task. Okay, so for example, when you ask or when you set a particular examples, like when a when a child asks for what is when a child asks to a to a grandpa, hey, what is the so how can I be strong in life? You provide the example as the grandpa. Hey, you should be well someone that must have responsibility from himself, among other things, blah blah blah. And when the child asks again, let's say in this case, hey, what is anti-fragility? Let the models perform the task. And the second principle is give the model time to think. And by that, this is something, okay, and by that is, so if a model is making reasoning errors by rushing to an incorrect conclusion, you should try to refrain with the query to request a chain of series of relevant reasoning. So, if the model is giving you incorrect conclusion, you should try to reframe the query. You should try to reframe the query as a series of steps or change of relevant reasoning before the model provides its final answers. Another way to think of this is if you give a model that is too complex, okay, give the model time to think. If you give a model that has too complex for it to do in a short amount of time or in a small number of words, it makes up guess which is likely to be incorrect. So also, and this also happens to a person too. If you ask someone to complete a complex math question without time to word the answer first, they will out the so they will also likely make mistake. So in these situations, you can instruct the model to think longer about a problem, which means it is spending more computational effort on the task. So in other words, it's like if you give a model time to, so if you give a model, yeah, if you give a person, this is also happens to persons. So give the model time to think. You can think of this as if you give a person a complex math questions without time, yeah, a complex math questions without time to work the answer first. Okay. So if you ask someone to complete, or if you ask to someone to complete a complex math questions without time to work on the answer first, they will also likely to make mistakes. And in this situation, you can instruct the model to think longer about the problem, which means it is spending more computational effort on the task. So, the TLDR of this, give the model time to think, is that if you're getting incorrect conclusions from your model, you should try to reframe that question, or you should try to reframe that query to a change or series of relevant reasoning before the model provides its final answers. So you give a set of, so you give a series of reasoning, of relevant reasonings before the model provides the final answer. So and another way to think of this is much like a person, where you ask them to perform, or when you ask them to complete a complex math questions without giving times to work the answer first, exactly, yeah, without complex math questions, without time to work, without time to work the question, without time to work the answer first, they will likely, they will also likely to make mistakes. So in this situation, you can instruct the model to think longer about a problem, which means it is spending more computational effort on the task. So tactic one is specify the step to complete a task. Step one, step two, step three, step M. And the other is instruct the model to work out its own solution before rushing it to a conclusion. And also it's important to look at the limitations here. Okay? At the limitations here. And the limitations here. Okay. Hmm. So now let me take a look at the next section. Right. So level three. No, because I have this on freelance or education. I think I have this on educational. Ah, no, this is on here. Open always this in this tab. All right. So the other is the iterative.
When I've been building applications with large language models, I don't think I've ever come to the prompt that I ended up using in the final application on my first attempt. When I've been building applications with large language models, I don't think I've ever come to the prompt that I ended up using in the final application on my first attempt. And this isn't what matters. As long as you have a good process to iteratively make your prompt better, then you'll be able to come to something that works well for the task you want to achieve.
You may have heard me say that when I train a machine learning model, it almost never works the first time. In fact, I'm very surprised if the first model I trained works. I think with prompting, the odds of it working the first time is maybe a little bit higher, but as Isa is saying, doesn't matter if the first prompt works. What matters more is the process for getting to prompts that works for your application. So with that, let's jump into the code and let me show you some frameworks to think about how to iteratively develop a prompt. All right. So if you've taken a machine learning class with me before, you may have seen me use a diagram saying that with machine learning development, you often have an idea and then implement it. So write the code, get the data, train your model, and that gives you an experimental result. And you can then look at that output, maybe do error analysis, figure out where it's working or not working, and then maybe even change your idea of exactly what problem you want to solve or how to approach it, and then change implementation and run another experiment and so on and iterate over and over to get to an effective machine learning model. If you're not familiar with machine learning and haven't seen this diagram before, don't worry about it. Not that important for the rest of this presentation. But when you are writing prompts to develop an application using an LLM, the process can be quite similar, where you have an idea for what you want to do, the task you want to complete, and you can then take a first attempt at writing a prompt that hopefully is clear and specific, and maybe, if appropriate, gives the system time to think. And then you can run it and see what result you get. And if it doesn't work well enough the first time, then the iterative process of figuring out why the instructions, for example, were not clear enough, or why it didn't give the algorithm enough time to think, allows you to refine the idea, refine the prompt, and so on, and to go around this loop multiple times until you end up with a prompt that works for your application. This too is why I personally have not paid as much attention to the internet articles that say 30 perfect prompts, because I think there probably isn't a perfect prompt for everything under the sun. It's more important that you have a process for developing a good prompt for your specific application. So let's look at an example together in code. I have here the starter code that you saw in the previous videos. Have import OpenAI, import OS. Here we get the OpenAI API key, and this is the same helper function that you saw as last time. And I'm going to use as the running example in this video the task of summarizing a fact sheet for a chair. So let me just paste that in here. And feel free to pause the video and read this more carefully in the notebook on.
Okay. Much better. Building tables and more. Several options of shell color as base finish. Overview. Generate a marketing product description. A marketing product description from a product fact sheet. Part of a beautiful family of mid-century inspired office furniture, including filing cabinet, desk, bookcase, meeting tables, and more. Several options of shell colors are base finishes, available with plastic bag and from upholstery and full upholstery. In 10 fabric, 6 leather options. Assert violation. What the hell is this? But this is not okay. Okay. Upholstery or full upholstery. Upholstery. Base finish options are stainless steel, matte black, gloss white, or chrome. Chair is available with or without armrest. Suitable for home or business setting. Qualified for contract use. Constructions. 5-wheel plastic coated aluminum base. Pneumatic chair adjusts for easy raise lower action. Dimensions: width, deep, height, height, C deep. Options: soft or hard floor caster options. Two choice are set from density, medium, materials, country of origin. So this is the fact sheet chair. Generate a marketing product description from a product fact sheet.
the left if you want. But here's a fact sheet for a chair with a description saying it's part of a beautiful family of mid-century inspired and so on. Talks about the construction, has the dimensions, options for the chair, materials, and so on. Comes from Italy. So let's say you want to take this fact sheet and help a marketing team write a description for an online retail website. Let me just quickly run these three, and then we'll come up with a prompt as follows. And I'll just paste this in. So my prompt here says, your task is to help a marketing team create a description.
Clearly identify different inputs.
For a retail website of the product based on a technical fact sheet, write a product description, and so on. Right. So this is my first attempt to explain the task to the
Exactly,
large
first
language
attempt.
model. So let me hit Shift Enter, and this takes a few seconds to run. And we get this result. It looks like it's done a nice job writing a description, introducing a stunning mid-century inspired office chair, perfect edition, and so on. But when I look at this, I go, boy, this is really long. It's done a nice job doing exactly what I asked it to, which is start from the technical fact sheet and write a product description. But when I look at this, I go, this is kind of long. Maybe we want it to be a little bit shorter. So I have had an idea. I wrote a prompt, got a result. I'm not that happy with it because it's too long. So I will then clarify my prompt and say, use at most 50 words to try to give better guidance on the desired length of this. And let's run it again. Okay, this actually looks like a much nicer short description of the product.
And
Introducing a
copywriters
mid-century inspired office chair,
available
and
in a
so
range
on. Five view, just
of
yeah, both stylish and practical.
shell colors and base
Not
finish.
bad. And let me double check the length that this is. So I'm going to take the response, split it according to where there's spaces, and then print out the length. So it's 52 words. It's actually not bad. Large language models are okay, but not that great at following instructions about a very precise word count. But this is actually not bad. Sometimes it will print out something with 60 or 65 and so on words, but it's kind of within reason. Some of the things you could try to do would be to say use at most 3 sentences. Let me run that again. But these are different ways to tell the large language model what's the length of the output that you want. So this is 1, 2, 3. I count 3 sentences. Looks like I did a pretty good job. And then I've also seen people sometimes do things like, I don't know, use at most 280 characters. Large language models, because of the way they interpret text, using something called a tokenizer, which I won't talk about, but they tend to be so-so at counting characters. But let's see, 281 characters. It's actually surprisingly close. Usually a large language model doesn't get it quite this close. But these are different ways they can play with to try to control the length of the output that you get. But let me just switch it back to use at most 50 words. And there's that result that we had just now. As we continue to refine this text for our website, we might decide that, boy, this website isn't selling direct to consumers, it's actually intended to sell furniture to furniture retailers that would be more interested in the technical details of the chair and the materials of the chair. In that case, you can take this prompt and say, I want to modify this prompt to get it to be more precise about the technical details. So let me keep on modifying this prompt. And I'm going to say, this description is intended for furniture retailers, so it should be technical and focus on materials products are constructed from. Well, let's run that. And let's see. Not bad. It says, coated aluminum base and pneumatic chair, high quality materials. So by changing the prompt, you can get it to focus more on specific characters, on specific characteristics you want it to. And when I look at this, I might decide, at the end of the description, I also wanted to include the product IDs. So the two offerings of this chair, SWC 110, SOC 100. So maybe I can further improve this prompt. And to get it to give me the product IDs, I can add this instruction at the end of the description, include every 7-character product ID in the technical specification. And
It's providing its
let's run
conditions
it
to the check whether
and
condition
see
is
what happens.
satisfied, which is
And
also
so it
following is part
says
of the
HD7
principles
essentially
that we're
inspired
applying.
office chair. Shell colors talks about plastic coating aluminum base, practical,
Is
some
it tactic
options.
number 3
Talks
from the
about the
principle
two
1?
product IDs. So this looks pretty good. And what you've just seen is a short example of the iterative prompt development that many developers will go through. And I think a guidelines is in the last video, you saw Isa share a number of best practices. And so what I usually do is keep best practices like that in mind, be clear and specific, and if necessary, give the model time to think.
And get the
With
model
those in
time to
mind,
think.
it's worthwhile to often take a first attempt at writing a prompt, see what happens, and then go from there to iteratively refine the prompt to get closer and closer to the result that you need. And so a lot of the successful prompts that you may see used in various programs was arrive at an iterative process like this. Just for fun, let me show you an example of a even more complex prompt that might give you a sense of what ChatGPT can do, which is I've just added a few extra instructions here. After the description, include a table that gives the product dimensions, and then format everything as HTML. So let's run that. And in practice, you would end up with a prompt like this, really only after multiple iterations. I don't think I know anyone that would write this exact prompt the first time they were trying to get the system to process a fact sheet. And so this actually outputs a bunch of HTML. Let's display the HTML to see if this is even valid HTML and see if this works. And I don't actually know if it's going to work, but let's see. Oh, cool. All right, looks like it rendered. So it has this really nice looking description of a chair, construction, materials, product dimensions. Oh, it looks like I left out the use at most 50 words instruction. So this is a little bit long, but if you want that, you can even feel free to pause the video, tell it to be more succinct and regenerate this and see what results you get. So I hope you take away from this video that prompt development is an iterative process. Try something, see how it does not yet fulfill exactly what you want, and then think about how to clarify your instructions, or in some cases, think about how to give it more space to think to get it closer to delivering the results that you want. And I think the key to being an effective prompt engineer isn't so much about knowing the perfect prompt, it's about having a good process to develop prompts that are effective for your application. And in this video, I illustrated developing a prompt using just one example. For more sophisticated applications, sometimes you will have multiple examples, say a list of 10 or even 50 or 100 fact sheets, and iteratively develop a prompt and evaluate it against a large set of cases. But for the early development of most applications, I see many people developing it sort of the way I am with just one example. But then for more mature applications, sometimes it could be useful to evaluate prompts against a larger set of examples, such as to test different prompts on dozens of fact sheets to see how its average or worst case performances on multiple fact sheets. But usually you end up doing that only when an application is more mature and you have to have those metrics to drive that incremental last few steps of prompt improvement. So with that, please do play with the Jupyter Code Notebook examples and try out different variations and see what results you get. And when you're done, let's go on to the next video where we'll talk about one very common use of large language models in software applications, which is to summarize text. So when you're ready, let's go on to the next video.
So that'll be all for this video. Take care. Bye bye.